Hello, geometry. Welcome to the beginning of topic 1, foundations of geometry. All right. So in this chapter, we are going to learn the building blocks of geometry so that you can attack this entire year with confidence. So in section 1, or lesson 1, we're going to talk about measuring segments and angles, two of the major components of geometry. Now, down here in this standard, I'm going to highlight this word definitions, okay? Uh, Geometry has a lot of words in it. Sorry, it just does. So we have to get our definitions down pat. It'll make your life totally easier later on in the year. So do your best to make that happen. Okay, so we have some undefined terms. These are the basic building blocks of geometry, as it says right here. So first you have what's called a point. So symbolically, a point is this dot with the capital letter. Typically, when we deal with points, we're talking about endpoints of segments. Or we're going to talk about a vertex in a polygon or an angle of some sort, okay? That's where you'll see points this year. Next, we have lines. Lines are used a lot, especially when we talk about parallel and perpendicular lines. So here is a line. Notice that there are 2 points on that line. You have to have 2 points to make a line. That's one way to name it. So you call this line AB. Notice the line above it. You could also call this line BA. Alphabetical order doesn't matter. Okay. And then you see this lowercase, that's an L. That's not a point. There's no dot. You can also call that line by that lowercase L, line L. Okay. And then last but not least, you have planes. I'm not going to focus so much on planes because everything we do involves planes in our geometry class. We are doing what's called Euclidean geometry. Euclid, I forget what his nickname was, the father of geometry or something like that. So you're doing Euclidean geometry. And Euclidean geometry is synonymous with plane geometry. Okay. There are different types of geometry. There's spherical geometry. I think there's hyperbolic geometry. It's got some weird stuff. But again, we're doing Euclidean geometry, so we're all about the plane and flat surfaces. Now, we will do three-dimensional figures later, but they also involve planes. Okay, so now enough with the undefined terms. Let's go to the defined terms. All right, so these all involve parts of lines. All right, so first thing we have here is we have what's called a segment. Now, again, segments are huge in this class, right? That's how we build all our shapes, with segments. So a segment consists of 2 endpoints. So notice here, starts at A, stops at B. It has definite length, as we'll talk later, and that's how you name it, with its endpoints, AB. Notice the line, or the segment above AB doesn't have arrows, so it's not a line. And again, you can also call it segment BA. Okay. Array. Array is like one directional part of a line. So notice that it does have an endpoint where it starts, and then it goes off in one direction through another point, and there's the arrow. Notice that you do call this ray MN. You cannot call this ray NM. You can't call it ray NM because it doesn't start at N and go through M. It starts at M and goes through N. Okay. Just because this ray is going to the right, that doesn't mean we name it like, to the right. Any ray. So we could have a ray like this. Ray MN could be going like this. Ray MN. And we would still name it just like that. Okay. So that arrow in the naming always starts with the endpoint and ends with the second point. Next, we have what are called opposite rays. And opposite rays are 2 rays that have the same endpoint. So notice here that these 2 opposite rays are TS going this way. And then I'll change my color to blue, and we have TU going that way. Now, together, it's very important that we notice that they make a line, right? So they're on the same line together. And again, notice that that common point T that they share is the first point in both namings, TS and TU, because that's where the race starts. They just go in opposite directions. And then last but not least, let's talk about angles. And again, just like segments are very important, angles are equally important. Angles are formed by two rays that share an endpoint. So here you have ray QR and ray QP. This endpoint Q is called the vertex. So there's where a point can be used as a vertex. Very, 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 very important. Now there's multiple ways to name angles. If you have the angle all by itself, you just need the vertex, angle Q. Now, if the angle is around other angles, you should use three letters, a letter on one side, then the vertex, then a letter on the other side. So notice the vertex is in the middle. You could have also named this angle RQP. Again, alphabetical order doesn't matter. Or, and we'll do this with parallel lines, if you see a number inside the angle, now don't confuse that with the measurement, right? You would see degrees if it was a measurement. This is not a, it's not a 2-degree angle. This is angle 2. You can name it like angle 2. Okay, so let's do, I think, some problems now. Once we got this vocab out of the way. Yeah, nice. Okay, so it says, example 1, find segment length. How can you find the length of segment CD? Well, if I look on this picture here, all right, I see C is right here at the 1, and I see D is over at the 4. So I think the easiest way is just count 1, 2, 3. And there's the length of CD. So CD is just equal to 3. And I did that by counting. So that's one way. That's the counting way. Now, the other way, or, is you could actually take these numbers underneath the C and D and you can actually subtract them. So to find CD, you could take the farther number 4 and subtract the closer number 3. And there's another way to get CD equals 3. Okay? So again, when you count, every time you go, 1, 2, 3. When you count, when you move, that's when you count. Okay, so this introduces us to what's called the ruler postulate. So first of all, a postulate, and I don't think this was explained, a postulate is a statement of accepted fact. So I always like to say, like, uh, when a parent tells you to do something, you say why. They say because I said so. That's a postulate. Because I said so. Ruler postulate says every point on a line can be paired with a unique real number. This number is called the coordinate. So what they're saying here is on this ruler. Rulers consider a line here. X corresponds with the 3 measurement, and Y corresponds with the 7. So the coordinate of X is 3, the coordinate of Y is 7. This is just sort of getting you an idea of like identifying where points are on a line. Not a huge deal, okay? Uh, the bigger idea is right here, distance on a line, right? So the distance between any 2 points, X and Y, is the absolute value of the difference of their coordinates. So the distance is the absolute value. In Algebra 1, you all should have talked about absolute value. The reason that we use absolute value here, absolute value, is because absolute value ensures that things are positive. Right? We want to make sure our distances are positive. So notice here, when you take the absolute value of 7 minus 3, inside the absolute value is 4, right? And of course, the absolute value of 4 is positive 4. So that's one way to get that length. But you could also do 3 minus 7. Well, this time you'll get negative 4, but you're going to take the absolute value. And when you take the absolute value, you still get 4. Okay? So that's why the absolute value is important. Okay, next. All right, so now we're going to do what is the length of a segment. So what is KL? So it says use the ruler postulate to find the coordinates of K and L. A postulate is a statement that is assumed to be true. So again, here's that idea of what a postulate is, right? Assumed to be true. So again, you don't question it. It just is what it is, all right? So in this picture here, I see K and I see L. So K's coordinate is 12. L's coordinate is 16. So to find KL, you must use the absolute value of either 16 minus 12, or you could flip the order, 12 minus 16. No matter how you slice it, you're going to get 4 or negative 4, and the absolute value of those is positive 4. So KL has a length of 4. Okay, next we're going to look at the segment addition postulate. If points A and B are on the same line with B between A and C, then AB plus BC equals AC. This is a very, 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 very important idea. Again, it's a postulate. So if we take a look here on this line right here, on this line AC, so we have this segment AB. I'm going to call that X. We have this segment BC. I'm going to call that Y. Well, together they go all the way from A to C, and I'm going to call that Z. So very simply, if we add the length X plus the length Y, you're going to get the length of Z. This to me is a very much more of an algebraic notation for you to understand because you're coming from algebra, but this is segment addition. AB plus BC equals AC. Notice 2 letters per segment. Now over here in this picture, we can see that they have AB written as 5, BC written as 5, and then AC going all the way across is 10. And again, if you add 5 plus 5, you do get 10. Now I'm going to click this button. Let's see what happens. I've never done this before. This is going to take me to the website. I think I'll have to enter my information. And it should take me to this page where I can actually play around with the exploration tool. Cool. And what it says is drag the points A, B, and C to explore the segment addition postulate. So look what I can do. I can change the lengths. So let's change. Let's see if we can make B doesn't want to move. Let's change. So AB is 4. And then let's try to just make things move as you move. Okay. Anyway, so AB is about 3, BC is about 3.5, right? So 3 and 3.5 is 6.5, and notice that AC is around 6.5. So again, should make sense to you, right? Should make sense to you. All right, so let's do one question involving some algebra. Okay, so it says, oh, sorry. 1 second. There we go. Okay. Use the segment addition postulate. So it says points F, G, and H are collinear. If GH equals 16, what is FH? So we, in the end, want to find what FH is. This is our real question, right? Well, both of these expressions involve X. It would be nice to know what X is because if we know what X is, I think we can find what FH is. Well, they did give us this information. GH is 16, right? GH is right here. 2x plus 1 is representing GH. 16 is GH. So we know that 2x plus 2, I think I said 2x plus 2 equals 16. Let's solve this for x. Let's subtract 2 on both sides. 2x equals 14. Let's divide by 2. X equals 7. We have what x is. So I know that GH is 16. I can now find FG by plugging the value of x into 3x minus 1. So watch this. So FG equals 3x minus 1. FG is 3 times 7 minus 1. 3 times 7 is 21, minus 1 is 20. I now know that FG is 20. So if I want to find the length of FH, and I'll do it right here, I'm going to apply the segment addition postulate. FG plus GH, so this segment plus this segment equals FH. I know that FG is now 20. I found it. I was given that GH is 16. And now I can find FH by adding 20 and 16. So FH is 36. All right, so this was the first video. Second video is coming to finish lesson 1-1.